You drift at the edge of a quiet region of space, a place where starlight softens and the cosmic background hums like a distant choir. There is no urgency here, only quiet anticipation, as if the universe itself is holding its breath. And in that silence, a mechanical sun rises into view. The James Webb Space Telescope. It glows gently, its gold mirrors catching distant starlight thrown across vast cosmic rivers. It floats not as a cold machine, but as a witness, a sentinel forged to pierce the darkness and read the universe's oldest memories. Humans designed it to see farther than ever before, to observe structures so ancient their light has been travelling since the dawn of time. But what it sees is not what anyone expected. You drift closer, watching the telescope's giant honeycomb mirror reflect the faint glow of the deep sky. Each segment is a window into eras older than the theories that predicted them. Each reflection is a challenge thrown at the models humanity once trusted, because when James Webb opened its eyes, the universe looked back, and it was older, brighter, and far more complex than anyone imagined. The first shock came almost immediately. In regions where astronomers expected faint, fuzzy smudges, tiny infant galaxies barely formed, Webb found giants. Fully structured, mature galaxies, shining with organized spirals and vast clusters, appearing far earlier than the cosmic clock allowed. You drift into the field Webb first revealed, a tapestry of galaxies so distant their light began its journey when the universe was supposed to be in its infancy. The expectation was simple. The earlier the universe, the simpler the structures. Tiny, chaotic clumps of stars, proto-galaxies struggling to form, a cosmic toddler learning to stand. But that is not what you see. Instead, you find massive galaxies glowing with the brightness of hundreds of billions of suns. Their shapes are defined, not chaotic. Their structures are rich, not primitive. They appear as if they skipped the early stages entirely and jumped straight into maturity. This is the first fracture in the old models. You drift deeper into the field, weaving through the light of newborn giants. Some galaxies shine brighter than any theory predicted. Others contain heavy elements, materials that should have taken billions of years to accumulate through cycles of star birth and death. Yet here they are, existing in an era when stars were supposedly still learning how to shine. The cosmic timeline bends, the expected sequence collapses. The universe refuses to follow the script. You glide toward one particular galaxy, small by modern standards, yet impossibly old for its place in cosmic history. Its stars burn hotter than they should. Its light is too bright, too rich with metals. Every photon it emits is a contradiction, and James Webb captured them all. As you drift behind the telescope, you feel the weight of the mystery gathering like a storm. The old narrative of a universe born in a sudden flash, expanding rapidly, slowly forming stars and galaxies over billions of years, that narrative begins to tremble. Webb did not just observe early galaxies, it observed impossibilities. Too many stars too soon. Too much structure too early. Too much complexity for a universe supposedly only a few 100 million years old at the time these lights were born. Astronomers began calling these the impossible galaxies. But the universe has no concept of impossible, only what is. You drift further into the ancient light, letting the galaxies pass around you like lanterns suspended in an infinite ocean. Their shapes whisper an unsettling truth. The universe was never as young as humans assumed. It was never the simple newborn painted in textbooks. It was complex from the start, or perhaps the start is not where anyone thought it was. James Webb did not break the universe. It revealed the cracks that were always there. The telescope continues surveying the deep sky, and each new image adds another fracture to the old models. The more Webb sees, the more the theories strain. The timeline groans under the weight of unexpected maturity. The cosmic clock refuses to tick the way humans predicted. You drift back toward Webb, feeling the enormity of what its mirrors have captured. This telescope is not merely showing new objects, it is rewriting cosmic history, or revealing that the history humanity believed in was written incorrectly, and the fractures deepen. Some galaxies appear too massive to have formed in so little time. Others appear to have undergone star formation at speeds that outpace the limits of physics as previously understood. Some structures appear eerily similar to modern galaxies, even though billions of years supposedly separate them from such maturity. The universe is not behaving like a universe with a single simple beginning. It is behaving like something older, something more layered, something cyclical, complex, perhaps eternal. You drift onward from Webb into the deep field it revealed. The galaxies glow like embers in an ancient fire. They are not the cosmic infants the standard model demanded. They are echoes of something grander, hints of a universe with a story far deeper than a one-time creation event. The mystery grows, and the models strain under its weight. Ahead lies more evidence, more contradictions, more light that should not exist so soon. And your journey continues. You drift deeper into the Webb deep field, leaving behind the first layer of impossible galaxies. Ahead lies a region even more troubling to conventional cosmology, a region where the light grows unexpectedly intense, where galaxies shine with the mass and structure of systems that should have required billions of years to assemble. But these galaxies existed when the cosmos was supposedly still in its childhood. You approach the first of these massive structures. It shines with a glow so dense and packed that every photon feels heavy. The galaxy is compact, smaller than modern giants, yet containing almost as many stars. It is a cosmic paradox, too small to hold such mass, too young to hold such age. To grow a galaxy like this, the universe would have needed time it wasn't supposed to have. Yet here it stands, billions of suns strong, a monument to a timeline that does not add up. You drift into its halo, feeling the gravitational weight press gently against your path. Stars swell tightly around the core, forming patterns that require stability, maturity, and countless cycles of gravitational sculpting. This should not exist so early. This cannot exist so early. And yet here it shines. Webb found not one such galaxy, but many. Dozens, then hundreds, then more. Each one shatters another assumption. You drift toward another massive early galaxy. This one is more diffuse, its light spread across a broader region. Young stars blaze within it, but the galaxy contains heavy elements forged in previous generations of stars that should not have had time to live and die in this early era. Yet here they are, alive in the evidence Webb captured. The mystery deepens. To create heavy elements, stars must be born, live, explode, and recycle their matter into new stars. This takes time, vast stretches of it. But these early galaxies contain metals far beyond what a newly formed universe should have produced. Every atom you encounter whispers the same contradiction. The universe is older than the models insist. You drift onward, entering a region where the galaxies grow even larger, even more massive, even more structured. Webb revealed some galaxies that appear to contain hundreds of billions of stars, as many as the Milky Way, yet existing at a time when galaxies were supposed to be tiny, chaotic, malformed. But these are not malformed, they are refined, organized, majestic. You drift alongside one such behemoth. Its disk is faint, not fully formed, but its core burns with ancient brilliance. Star clusters orbit it in tightly bound patterns. The gravitational architecture resembles that of galaxies far older. Yet this structure existed at a time when the universe should have only begun assembling its first pieces. Every detail is a challenge. Every orbit is a contradiction. Every cluster is a rebellion against the established models. Astronomers struggled to explain this. Some suggested rapid star formation. Others proposed exotic processes. But each explanation required bending the models further and further until the models themselves began to look fragile, stretched thin over evidence they could no longer support. You drift into the void between the massive galaxies. Here, Darkness prevails, but not emptiness. Faint whispers of starlight scatter through the region, remnants of even more early galaxies Webb uncovered. There are too many, too bright, too evolved, too massive. The early universe was not the cosmic nursery it was expected to be. It was a bustling metropolis of galactic giants. You drift closer to another bright cluster. This one contains multiple galaxies, packed tightly together, interacting, merging, exchanging streams of stars. This level of cosmic choreography requires maturity and time, not the chaotic infancy the standard model predicted. The universe, even at its earliest observable stages, behaves not like a newborn, but like something ancient beginning another cycle. The further you drift, the clearer the pattern becomes. Webb is not revealing anomalies. Webb is revealing the true nature of a cosmos far older and more complex than the models allowed. And as the contradictions pile up, a new question emerges. If the universe was already so mature at such an early time, what does that say about its true age? You drift out of the cluster, feeling the weight of the revelations growing behind you like a rising tide. Ahead lies another mystery, not of massive galaxies, but of cosmic objects that should not exist in a young universe at all. Objects older than the models permit, stars too ancient, black holes too big, light too enriched, and Webb saw them all. You drift away from the impossible early galaxies, moving deeper into the region, where James Webb revealed something even more unsettling. Stars that appear older than the era in which they exist. These stars burn with a quiet, ancient glow. Their light is not the fierce fire of newborn giants. It is the softened radiance of objects that have lived long enough to undergo changes that, according to the models, should require billions of years. Yet here they are, shining when the universe was supposedly only a few 100 million years old. You descend toward one such star cluster. It is small, packed tightly with stars that share a strange trait: their metallicity. The abundance of elements, heavier than hydrogen and helium, is too high. These elements are forged through cycles of star birth and death. They require generations of stellar evolution, generations that should not have existed so early. You glide through the cluster, feeling the starlight ripple across your path. Some stars are enriched with carbon, oxygen, and iron, elements that should have taken immense time to accumulate. Stars this mature should belong to a universe far older, but Webb found them near the supposed beginning. You approach one particularly bright star. Its atmosphere contains traces of heavy elements that require multiple cycles of stellar creation and collapse. For this star to exist, the universe must have already lived through earlier eras of formation, eras the standard model does not acknowledge. This is not the light of a newborn cosmos. This is the light of something that has existed far longer than expected. You drift deeper into the region, exploring more of Webb's findings. You pass by a galaxy where ancient red giant stars glow with the unmistakable signature of long-term evolution. Their light curves gently outward, displaying properties that take eons to develop. Yet their light began its journey at an epoch when these stars were supposed to be impossible. You float near a group of metal-rich stars, another contradiction. Heavy metals require supernovae to create them, and supernovae require long-lived stars to form, burn, and die. But these early stars contain metals from multiple generations of stellar life. How many cycles occurred before their formation? How much time did they need to exist? You drift onward, feeling the implications settling like cosmic dust along your path. If these stars truly contain the fingerprints of multiple stellar generations, then the universe must have existed long before the models assume. But the contradictions do not end there. Webb discovered stars that burn with unusual temperatures, too hot and too bright for their cosmic era. These stars appear to have formed from gas, enriched by previous cycles of star formation. Their existence demands one thing: a long cosmic prelude the standard timeline does not allow. You glide toward a region where Webb detected population 2 stars, stars with moderate metallicity, appearing at a time when only the first generation should exist. According to the standard narrative, the earliest stars, population 3, were massive, metal-free giants that lived short, intense lives. Only after their explosive deaths could metal-rich stars form. But Webb did not find these first-generation giants. Instead, it found their descendants. The model collapses under the contradiction. You drift across a galaxy, glowing with stars too evolved for a universe so young. You see red supergiants, blue-white giants, ancient dwarfs, each type requiring long spans of cosmic history, yet Webb reveals them at a time when the universe was supposedly just beginning to form stars. Slowly, the truth emerges like a rising light. The universe is not behaving like something with a single starting point. It behaves like something that has been cycling for far longer. A cosmos that has undergone previous eras of formation, destruction, and rebirth. These stars carry the chemical memory of cycles the models refuse to acknowledge. The more you drift, the more the evidence accumulates. Not isolated anomalies, but a pattern. A pattern of early maturity, a pattern of ancient complexity, a pattern of time stretching far beyond theoretical limits. You ascend from the cluster of ancient stars, rising into the surrounding void. Something else waits ahead, something even stranger. Black holes too large, too powerful, too early. And Webb saw them clearly. You drift forward into the next region, revealed by James Webb, a place where gravity itself becomes the mystery. Here lie the most troubling contradictions the telescope uncovered. Supermassive black holes sitting at the centers of early galaxies. Black holes so large they should have required billions of years to form. Black holes that should not exist in the early universe. Black holes that break every model designed to explain them. You approach the first of these monsters. It sits at the center of a distant galaxy, glowing with a quasar-like brilliance. The gas swirling around it emits intense radiation, revealing the presence of a black hole with a mass millions, or even billions, of times that of a star. But this black hole existed when the universe was only a small fraction of its supposed age. You drift closer, feeling the gravitational field ripple around the accretion disk. The black hole devours matter in spiraling streams of light. Jets of energy burst from its poles, stretching outward like cosmic lighthouses. This is not a young black hole. There is nothing primitive about it. It is fully formed, fully active, fully mature. But how? To form a black hole of this size, you would need immense time. Time for stars to form, burn, collapse, merge, and accumulate into something colossal. Yet Webb detected these giants in an era when not even the first galaxies were supposed to have finished assembling. The contradiction is overwhelming. You drift onward to another early galaxy. Webb revealed that it too contains a massive central black hole. And another. And another. Everywhere Webb looked, the same pattern emerged. Early galaxies hosting gigantic black holes. Not small seeds, not tiny gravitational embryos. Monsters, black holes that should not exist in a young cosmos. You glide through one galaxy, where the black hole's mass appears to rival the mass of the entire galaxy itself. A cosmic imbalance the models cannot explain. In the standard model, black holes grow slowly, over billions of years of mergers and accretion. But here, they appear instantly mature. The deeper you drift, the more the universe contradicts the theories. One black hole emits a blazing quasar, a beacon visible across cosmic eternity. Quasars require massive black holes to power them. Yet this quasar existed far earlier than any should. Another black hole reveals gravitational influence over a vast region, shaping the galaxy around it in ways that require long-term stability. But this stability should not have existed yet. According to the timeline, the universe was still turbulent, chaotic, assembling its first structures. And yet everywhere you look, you see maturity, you see structure, you see ancient signatures. Then you encounter something even stranger, evidence that some early black holes grew faster than physics allows. Their growth rates exceed theoretical limits. They violate the boundaries of accretion. They outpace the models designed to contain them. Black holes cannot grow this fast. Black holes cannot form this early. Black holes cannot shape galaxies so soon. But they do. They did. Webb saw them. You drift upward, leaving behind the swirling galaxies and their impossible black holes. A realization follows you like a shadow. These black holes are not anomalies. They are symptoms, signals, clues to a deeper truth. The universe is behaving like something ancient, something recycled, something that did not begin in a single explosive moment. The presence of these colossal early black holes suggests a universe with a history far longer than the models claim. A universe that has undergone cycles of formation and dissolution. A universe that remembers. You drift deeper into the darkness, following the trail Webb illuminated. A trail that leads into the next great mystery. A structure so large, so vast, so early, that it should not exist at all. A cosmic giant that defies the very fabric of the standard model. You drift forward, carried along a river of ancient light that James Webb has uncovered. The galaxies thin out, and the dark between them seems to deepen. But not for long. Ahead, a glow begins to gather. Not the concentrated glow of a single galaxy, not the tight radiance of a star cluster. This is broader, vast, a shimmering web stretching across space in patterns too large, too organized, too early. James Webb revealed cosmic structures that should not exist. Not yet, not so soon, and not according to the models. You glide closer. The glow resolves into filaments of galaxies, aligned in sweeping arcs, connected like nerves in a cosmic brain. These filaments stretch across distances so immense they seem like errors, hallucinations in the data. But they are real. You descend into one filament. Galaxies line up along its length, like beads strung on a gravitational thread. Their arrangement is too coordinated, too symmetrical. The universe should not have had enough time to assemble structures of this magnitude. Large-scale structure requires countless cycles of gravitational attraction. It requires interactions, collisions, mergers, and the slow choreography of matter drifting across cosmic distances. But here they are, fully assembled when the universe was supposed to be young. You drift along the filament for what feels like eternity. Galaxies continue in every direction, each one a luminous node in the cosmic web. Their distances span millions of light years. Their alignment requires long-term stability that a young cosmos could not provide. These structures are not the signature of chaotic early formation. They are the signature of maturity. You glide out of the filament and into a massive cosmic wall, a region where galaxies cluster tightly, forming a sheet of light stretching across unimaginable distances. Webb's observations revealed these walls far earlier than the models allowed. The standard model predicts that gravity needs billions of years to assemble such structures, but Webb found them already in place. You drift across the cosmic wall. Dense clusters of galaxies embrace each other with gravitational arms, forming knots in the web. Their arrangement resembles the cosmic structures seen in the modern universe, but these exist at a fraction of the supposed cosmic age. Evidence piles upon evidence. The universe didn't wait to become structured. It was structured from the start, or perhaps before the start. You descend toward one dense knot. Here, galaxies merge, collide, and reorganize in massive numbers. Their interactions release energy across the region, lighting it with the glow of countless stars forming simultaneously. This level of complexity is not expected so early. This level of organization is not possible so early. And yet here it is, written in the light Webb captured. You drift through the knot and encounter another unexpected revelation. Galaxy clusters with fully formed intracluster gas, massive reservoirs of hot plasma filling the space between hundreds of galaxies. Such plasma requires long-term star formation and supernova cycles to enrich and heat it. But Webb found it almost immediately after the supposed cosmic dawn. Another contradiction, Another fracture. You rise above the Webb, looking down at the interconnected structures sprawled across the void. The entire region resembles the cosmic web, seen billions of years later, yet this is the early universe, according to the standard model. If such structures exist this early, the timeline is wrong. If such organization appears so soon, the models are incomplete. If the universe was already this structured, it was never a young universe to begin with. You drift backward, letting the enormity of it settle. The cosmic web, the filaments, the walls, all appearing far too soon, imply a cosmos with a hidden history, a cosmos built upon previous cycles of collapse and rebirth. James Webb didn't just reveal new structures, it revealed an old universe wearing the mask of youth. You drift onward. Ahead lies another domain of mystery, one not of size or age, but of physics itself. James Webb observed objects that challenged the laws we thought were unbreakable. Forces behaving strangely, light bending unexpectedly, patterns that defy gravitational predictions. The universe is not just older, it is stranger. And your journey continues as you drift deeper into the territory illuminated by Webb's observations. You begin to sense a different kind of tension. Not the weight of mass or the glow of stars, but the subtle distortion of laws. The universe behaves in ways that the standard model cannot fully explain. The fabric of physics itself carries anomalies. You glide into the first region where these strange behaviors emerge. Ahead lies a galaxy, whose rotation defies expectations. The outer stars move too fast. Their speeds should tear the galaxy apart, yet the galaxy remains stable, held together by forces not accounted for in conventional calculations. Webb's high-resolution data uncovered many such galaxies. Galaxies rotating too quickly, galaxies too stable, galaxies obeying gravitational rules that don't match the predictions. The explanation? It isn't clear. Dark matter was supposed to account for these discrepancies, but Webb's precision exposed new inconsistencies. Galaxies whose motion suggests even dark matter's distribution isn't behaving as predicted. Some galaxies lack the expected dark matter signature entirely. You drift closer, feeling the gravitational field ripple unpredictably. Not chaotic, but wrong. Wrong for the model, right for the universe. Beyond this galaxy lies another anomaly. Webb detected stars forming far too efficiently, at rates that violate established physics. Star formation should require slow cooling, long accumulation, stable clouds. Yet in the early regions, Webb observed, stars ignite rapidly, in massive bursts, suggesting physical conditions that should not have existed yet. But they did. You drift toward a region filled with the ultraviolet glow of extreme star formation. The density is too high, the temperatures too balanced, the collapse too precise. Somehow, matter organizes itself faster than the models allow. The physics is not broken, the models are. You glide onward and encounter something even stranger. Galaxies glowing with unexpected spectral signatures. Their light indicates processes not accounted for in the old theories. Chemical reactions occurring too early. Ionization patterns inconsistent with the predicted timeline. Heavy element signatures appearing before the universe should have produced them. Every photon defies the physics of a young universe. You drift farther still until you reach one of the most shocking discoveries, the unexpectedly smooth nature of early cosmic matter. According to the models, the early universe should have been turbulent, chaotic, filled with density fluctuations. But Webb's observations reveal regions that are surprisingly uniform, too even, too calm for such an early epoch. The physics of these regions does not match the expected behavior of a universe fresh from a violent beginning. Instead, the matter behaves like something that has settled, something that has relaxed, something that has existed for longer. You move into a void where gravity behaves strangely, light bends more than predicted, space seems smoother than expected. The early fabric of space-time appears too refined, as though shaped and reshaped across cycles. Even the cosmic background radiation once considered the strongest evidence of a single beginning, shows patterns that Webb's findings complicate. Subtle anomalies that were once dismissed now take on new meaning. Patterns once attributed to noise now align with Webb's deeper observations. The physics of the early universe appears too sophisticated. You drift back, feeling the enormity of these revelations press around you. James Webb didn't just observe galaxies, it observed contradictions woven directly into the laws governing the cosmos. The universe is not following the script must change, and ahead lies even more evidence, not just physical anomalies, but patterns that repeat across scales, implying something deeper. A universe not born once, but shaped across epochs. A universe that cycles. A universe that remembers. You drift into a region where James Webb's observations reveal something subtler, yet far more profound than any single anomaly. It is not just the existence of ancient stars, oversized black holes, or premature galaxies that challenges the models. It is the patterns repeating across eras where they should not exist. Patterns of structure, patterns of formation, patterns of behavior. The universe is not supposed to repeat itself so early, yet Webb sees echoes everywhere. You approach a spiral galaxy, glowing faintly in the ancient deep. Its arms sweep outward in elegant curves. Its central bulge is compact and bright. Its halo glimmers with old stars. This structure resembles modern spirals, but it existed when spirals were not supposed to exist at all. The pattern has appeared too soon. You drift through the galaxy's arms, watching star clusters arranged in familiar hierarchies. Clusters forming along dense filaments, spaced evenly, shaped by gravitational dynamics that usually require billions of years to refine themselves. But these are not late-stage structures, they are early. Too early. Webb finds similar structures again and again, repeating across different regions, different distances, different depths of cosmic time. Spiral patterns, barred patterns, disk patterns, even ring-like formations. The universe behaves as though it has seen these shapes before, as though it has practiced them. You drift farther and find repeating alignments in galaxy groups, trains of galaxies forming arcs that resemble later stage cosmic structures. Galaxy pairs locked in stable gravitational dances that should not have been stable so soon. Triplets and quartets arranged in patterns identical to those found in much later epochs. Webb showed that the universe was not experimenting with new forms. It was refining old ones. You glide through a cluster resembling the Coma cluster, except this one formed far earlier. Its galaxies display the same density relationships, the same spacing, the same gravitational hierarchies. Patterns repeated. You drift upward, watching another structure emerge, an early elliptical galaxy whose light profile matches modern ellipticals almost exactly. Ellipticals usually require mergers of spirals, chaotic interactions, billions of years of violent reshaping. But here is an elliptical that appears fully matured prematurely. Another pattern, another repetition, another fracture. The more you drift, the clearer the truth becomes. The universe at its earliest observable stages looks suspiciously like itself billions of years later. The standard model requires slow evolution, but Webb sees accelerated echoes, repeating across time like fractal signatures. You approach a faint nebula glowing with heavy element emission lines. Its pattern of enrichment mirrors nebulae in the modern universe, despite existing when there should not have been enough time for such enrichment. Again, the pattern repeats. You drift past molecular clouds whose density distributions resemble those in contemporary star-forming regions. They exhibit the same turbulent spectra, the same collapse signatures, the same fractal geometries. How does a young universe mimic a mature one? How do early patterns mirror future patterns? Why does the cosmos behave like something familiar with its own structure? You rise higher, thinking back to the fractal nature of coastlines, clouds, trees. repeating patterns across scales. The universe itself seems to exhibit a similar fractal nature, one that should have required vast spans of time to iterate upon itself. Yet Webb sees fractal repetition across epochs that supposedly occurred only a few 100 million years after the cosmic beginning. Slowly, a deeper insight emerges. The universe may not be repeating patterns because it evolves quickly. It may be repeating patterns because it has done this all before. James Webb reveals not a young universe experimenting with form, but an ancient system echoing designs shaped across infinite cycles. You drift into a region where Webb detected early cosmic voids, vast stretches of space relatively empty of galaxies. Voids require time to develop, time for matter to cluster elsewhere. Yet voids are present far too early. Even emptiness repeats patterns. You drift out of the void and into a dense region where galaxies align along filaments. These alignments match those seen in the present epoch. The same curvature, spacing, and density relationships. The universe is not learning how to form structures. It is remembering. Patterns repeat themselves across cosmic time because the universe carries memory, not metaphorical memory, but structural memory, encoded in gravity, matter distribution, and cycles of collapse and rebirth. James Webb uncovered these echoes, and the echoes point to a cosmos older than any single timeline. You drift onward, and ahead you sense something deeper still, not just repeating patterns, but cycles written directly into the large-scale structure. Webb's observations do not merely hint at cycles, they scream them. And your journey now moves toward the heart of that revelation. You drift into a region where the cosmic web stretches out like a titanic neural network. Filaments connect nodes, nodes connect clusters, clusters shape superclusters. Everywhere you look, the structure feels alive, pulsing, breathing, evolving across time. But in the data James Webb revealed, something astonishing emerges. Cycles hidden within the very architecture of the cosmic web. Not literal loops, not perfect circles, but recurring structural motifs suggesting repeated eras of formation and dissolution. You approach a superdense knot of galaxies. Their arrangement exhibits symmetry, unusual for a supposedly young universe. Their alignments resemble structures seen far later in cosmic history, patterns that require previous gravitational shaping. It is as if this knot formed not once, but many times before. You drift inward, observing the positions of galaxies. Their distribution follows specific ratios identical to those seen in much later clusters. This repeating geometry suggests the universe prefers certain shapes, certain efficiencies, certain gravitational configurations. And preferences imply practice. Practice implies repetition. Repetition implies cycles. You rise above the knot and glide along a filament bridging two clusters. This filament carries signatures of gravitational relaxation, the smoothing effect that occurs only after long periods of matter flow. But this filament existed during an era too early for such smoothing to occur. Another cycle hint, another echo. You travel down the filament, tracing its density variations. They follow fractal patterns repeated across multiple scales and epochs. These fractals imply a multi-cycle process: formation, dissolution, reformation. The universe is not building these structures for the first time. You drift into a vast supercluster region that Webb detected, one far too developed for the early universe. Its shape resembles modern superclusters, yet it formed long before gravity alone could sculpt so vast a domain. The only explanation that fits the evidence: these structures have ancestral roots, not literal remnants, but patterns inherited from cycles of previous universes or previous epochs of this same universe. You glide deeper until you encounter a region where gravitational lensing reveals mass concentrations that don't match visible matter. The lensing patterns resemble those seen in mature cosmic epochs, again suggesting cycles of gravitational shaping. The universe behaves as if shaped by ancient precedents. You drift onward until the cosmic web flows into a void. Here, the absence of matter carries its own cycle signature. The void is too clean, too large, too refined to create such vast emptiness. Matter must have clustered efficiently for long spans of time. Yet this void existed far too early. Once more, the standard timeline bends under the weight of evidence. You rise higher, gaining a panoramic view of the entire region. The repeating patterns become unmistakable. The cosmic web is not the product of a single expansion event. Its structure carries the fingerprints of cycles of repeated density waves, repeated clustering tendencies, repeated gravitational imprints, repeated spatial gradients, repeated void distributions. These are not random, these are inherited. You drift between clusters and notice temperature gradients in intracluster gas that mirror those in modern superclusters. These gradients require extensive heating and cooling cycles, processes that cannot occur in a universe only a brief time removed from its supposed beginning. Webb's observations force a new interpretation. The cosmic web is not a first attempt at structure. It is a continuation. The universe behaves like a system that has been forming and reforming itself across untold eons. You drift away from the web, feeling the weight of the truth deepening around you. These cycles, these echoes, these inherited structures, they point toward a cosmos with a history older than the standard model allows. But the implications go further. The next revelations uncovered by Webb suggest something even more radical, that the cosmic clock itself does not tick uniformly. That time, the very flow of the universe, behaves differently across epochs. Another contradiction, another mystery, and your journey moves onward, deeper into the Webb universe, where time itself begins to warp. You drift into a region where James Webb's deepest observations begin to reveal something far more unsettling than galaxies forming too early, or stars aging too quickly, or structures appearing too soon. Here, in the faintest reaches of ancient light, Webb encounters distortions that whisper a shocking possibility. Time itself may not be behaving the way cosmology assumed. You glide through a stretch of space where light from distant galaxies carries unusual redshift signatures. The stretching of their wavelengths does not match the standard expectations. Some galaxies appear older than their redshifts imply, others appear younger. The relationship between distance and time, once considered the spine of cosmology, begins to flicker. It is as if the universe is hinting that time does not flow uniformly, that the rate of cosmic evolution is not constant, that the cosmic clock ticks differently in different eras. You descend toward a galaxy whose spectrum Webb recorded in exquisite detail. Its stars burn with a maturity that contradicts its redshift. According to the model, this galaxy should be young, full of hot primitive stars, still learning to assemble heavy elements. But its spectral lines tell a different story. It contains metals forged through multiple stellar generations. Its stellar populations appear aged. Its core burns with the glow of long-term gravitational shaping. This galaxy is too old for its redshift. Its clock runs fast, or our clock runs slow. You drift deeper. Webb found another galaxy with the opposite problem. It appears too young for its redshift. Its stars are extremely hot and metal poor, as if they only recently ignited. But its redshift places it at the same cosmic era as more mature galaxies. Time does not align between objects. The cosmic clock appears inconsistent. You glide into a region where Webb's data suggests startling variability in cosmic expansion rates, ton rates. Galaxies at similar distances show different apparent ages. Some appear to have evolved rapidly, others barely at all. These discrepancies are not small. They stretch the boundaries of the model until the fabric begins to tear. The deeper Webb looks, the less trustworthy the standard timeline becomes. You rise into the void above several galaxy groups, viewing them from afar. Their brightness, their mass, their structures all show evolution that should require billions of years. Yet Webb sees these traits already in place. The timeline collapses under its own assumptions. Time is not the simple, linear flow we believed it to be. You drift into another distortion, distance ladder inconsistencies. Webb's precision measurements of certain light signatures, from supernovae, from variable stars, from galaxies, conflict with previously established distances. These inconsistencies accumulate like fractures in a clock face. The Hubble tension, once a small crack, becomes a canyon. You find another anomaly. The luminosities of early galaxies don't match their supposed ages. Many shine far brighter than they should, as if they have had extra time or extra energy to form stars. Time accelerates for some objects. Time decelerates for others. You drift into the region where the cosmic background radiation subtly shifts. Webb does not observe the early universe directly, but it observes the structures that echo its conditions, and those echoes paint a picture of a universe where early time was not violently chaotic, but surprisingly calm. A calmness too stable, a smoothness too refined, a structure too mature. These are not the traits of a freshly ignited cosmos. These are traits of a cosmos that has endured far longer. You drift above a large cosmic void. Webb's observations imply that voids formed faster than expected, or time flowed differently within them. The structure of empty regions resembles those in the modern era almost exactly, suggesting processes occurred at speeds beyond predictions. You glide onward, sensing the universe's deeper truth rising through Webb's contradictions. Time may not be universal, time may not be absolute, time may not be young. You drift through a region of gravitational lensing, where light from background galaxies curves sharply around massive objects. But the lensing reveals another inconsistency, mass distributions that defy expected evolution rates. Massive halos appear too defined, gravitational wells appear too deep, dark matter clumps appear too mature. Time sculpted these structures, but time had no right to be so efficient. You ascend into the darkness above it all, letting the anomalies collect into a single realization. The universe is not a child racing to maturity. It is an ancient being wearing a youthful mask. James Webb pulled back that mask. What it revealed was not a linear story, but a layered one. Not a simple past, but a recursive one. The cosmic clock does not tick forward at a constant rate. It ticks with cycles, shifts, accelerations and plateaus. And the next layer of Webb's discoveries points toward a deeper mystery still. Not just how time flows, but how matter behaves in ways that suggest a far older cosmic history than any model accounts for. Ahead lies that revelation, and you drift toward it. You glide into a region where James Webb's most detailed spectral data reveals an extraordinary truth. Matter itself seems to carry memory. Not conscious memory, but structural memory, chemical memory, evolutionary memory. A memory too advanced for a supposedly young universe. You drift toward a massive cloud of interstellar gas, one that Webb studied with its infrared instruments. The cloud glows faintly with heat, its molecules vibrating in intricate patterns. But what the telescope found within this cloud shocked astronomers. Complex molecules that should have required long spans of time to form. You enter the cloud, watching dust particles swirl around you. Some contain carbon compounds that form only after repeated cycles of stellar life and death. Others contain silicates and metals forged in ancient stars. This cloud exists at a redshift, where such complexity should be impossible. Matter remembers. You drift deeper, passing through clumps, where Webb detected polycyclic aromatic hydrocarbons, molecules typically associated with evolved stars and supernova remnants. Their presence suggests previous cycles of chemical enrichment. cycles that should not have occurred yet, cycles that hint at an older universe. You glide into another region where massive gas clouds show signatures of heavy nitrogen and oxygen, elements requiring multiple generations of star formation. These signatures appear far earlier than models allow. Matter remembers its ancestors. You drift into a galaxy whose dust lanes contain crystalline structures, minerals that require processing in stellar interiors and violent supernova shockwaves. Yet they exist in a galaxy formed too soon. Matter remembers its past forms. You rise above the galaxy and glide into a nebula where Webb discovered surprising amounts of dust grains older than the universe's assumed age. Dust requires long-term recycling. Stars must live and die multiple times to produce enough of it. Yet here is dust enriched far too early. You drift toward another nebula where molecules form in ratios identical to those in the modern universe, a signature of equilibrium chemistry. Chemistry that requires immense time to stabilize. Matter remembers its chemistry. You venture deeper toward a star-forming region where the gas contains unusual isotopic ratios. These isotopes imply cycles of star birth and star death that should not have happened yet. Matter remembers cycles the timeline denies ever occurred. You drift above these regions and into the space between galaxies, intergalactic medium enriched with heavy elements. According to the Standard Model, this enrichment should take billions of years. Yet Webb observes it in eras where such enrichment should barely have begun. Matter remembers universal cycles. You glide toward a massive early galaxy cluster. Within it, Webb observed heavy elements spread throughout the intra-cluster medium, the space between galaxies. These elements come from supernova explosions and stellar winds, spread across vast regions by gravitational interactions over immense timescales. But this cluster formed too early for such deep enrichment. Matter bears the scars of cycles older than the model allows. You drift toward regions filled with ionized gas. The ionization levels imply previous waves of cosmic reionization, not the first but possibly the latest in a series. The universe does not behave like something undergoing its first revolution. It behaves like something undergoing one of many. Matter remembers the universe's breaths. You rise above the web of enriched gas, stars and galaxies. The realization deepens. James Webb is not showing us matter that is young. It is showing us matter that has been recycled across cosmic eras. Matter remembers past stars, past galaxies, past cycles, past universes perhaps. Everything Webb sees carries the imprint of events older than the standard cosmological timeline. And this memory leads to the next revelation, that the universe is not merely old, it may be eternally renewing itself, and Webb's data points directly toward that possibility. Ahead lies the territory where theories break and new interpretations begin. You drift into a region where James Webb's observations stretch the imagination beyond even the boldest theories. Here, the light grows faint, not because the universe is young, but because the universe is layered. In this dim territory, Webb detected something extraordinary. Signatures that resemble the leftovers of events predating the supposed beginning of the universe. You drift into this faint glow. Not bright, not structured, but patterned. The glow carries fluctuations that the Standard Model struggles to explain. They are too smooth in some regions, too irregular in others, as though shaped by forces that existed long before the supposed cosmic dawn. These fluctuations match neither early gravitational collapse nor simple quantum noise. They resemble something else. Echoes, residues, imprints. You glide deeper, feeling the soft tremors of these ancient signals. They behave like the final whispers of something that came before, a previous cycle, a previous universe, or a previous era lost to the standard timeline. Some physicists call these pre-Big Bang signatures. Others call them false positives, but Webb sees them clearly, and you now float among them. You drift toward a region where faint gravitational patterns ripple through space, patterns that do not align with the predictions of early inflation. These ripples are too coherent, too structured, too ordered for a universe fresh from a singular beginning. They look like residues of previous cosmic cycles. You descend toward a patch of sky where Webb recorded unusual temperature distributions in early light emissions. These distributions resemble what one would expect if the universe had undergone multiple expansions and contractions, not a single event. Each cycle leaves behind fingerprints. Webb is finally sensitive enough to see them. You glide through another anomaly, early galaxies, whose orientations and spin axes exhibit strange correlations across vast distances. These correlations suggest the universe may have inherited angular momentum from a previous cosmic cycle. Momentum does not appear from nowhere. It persists, it flows, it transfers across cycles like a baton in a cosmic relay. You drift farther and discover a region where infrared signatures reveal massive energy deposits, energies too large and too well distributed to have formed in the short timeline of the Standard Model. These deposits resemble the final radiation of a previous universe fading into the next. You rise above the glow and look outward. Now you see something subtle but unmistakable, faint alignments in galaxy patterns that should not exist if the universe began randomly. Certain galaxy clusters appear along preferred axes, certain voids align in repeating directions, certain large-scale structures echo earlier ones. This is not the universe's first attempt at forming structure. These are inherited tendencies, cosmic habits carried across cycles. You drift toward one of these preferred axes. It extends across millions of light years, guiding the orientation of galaxies like a compass that survived a cosmic reset. Webb's precision instruments detected these alignments with clarity the older telescopes could not reach. These alignments hint that the universe may not have emerged from pure randomness. Instead, it may have inherited structure from whatever existed before. You glide deeper into this axis and encounter more repeating patterns, density waves that match theoretical predictions of earlier cosmic bounces. A universe that collapses and re-expands would leave such signatures in its newly formed matter. Cycles imprint memory. Memory shapes cycles. You drift through the faint regions where these signatures reside, feeling the universe whisper through patterns older than any timeline proposed by modern cosmology. Webb shows a universe that does not resemble a creation event. It resembles a continuation. The anomalies are not mistakes, they are clues. Clues pointing toward a reality where the universe has done this many times. Formed, expanded, matured, collapsed, reformed, over and over, across spans too vast to conceive. James Webb did not simply look back in time, it looked across cycles. You drift into the final layer of these echoes, and something else emerges. Not just evidence of previous cycles, but hints of an unexpected truth. The universe may be evolving toward higher complexity with each cycle. Ahead lies the region where this becomes clear. You drift into a region where James Webb's deepest fields overlap with theoretical territory few dared to explore. Here, the evidence suggests something astonishing. Each cosmic cycle is not identical. Each cycle becomes more complex. You glide toward a forming galaxy cluster, illuminated by Webb's infrared eye. The cluster is young according to the standard timeline, but its structure is remarkably sophisticated. Its galaxies are arranged in balanced gravitational harmony. Its intra-cluster gas is enriched. Its dark matter distribution is smooth and mature. This is not the first time the universe has built such a structure. This is refinement, the result of cycles improving upon themselves. You drift closer to one galaxy within the cluster. Its stars are arranged in a pattern too precise for a first-generation universe. It carries the chemical signatures of multiple stellar generations, not just the minimum required for star formation, but an abundance of heavy elements that seems excessive for its supposed age. This galaxy is not primitive. It is advanced. It is the product of many cycles of stellar recycling. You move toward a nebula glowing softly in the cluster's halo. It contains dust grains with crystalline structures requiring extended periods of high heat and pressure, conditions that typically arise from repeated supernova cycles. But these grains exist too early. They are legacies, artifacts of inherited complexity. You rise above the cluster and drift into a region where Webb observed early quasars. These quasars emit enormous amounts of energy with surprising efficiency. Their host black holes appear to have formed not just rapidly, but with a structural elegance that suggests prior templates. Black holes in this era behave like experienced architects, not beginners, not first-timers. You glide further into the deep field where Webb revealed early star-forming galaxies with astonishing chemical uniformity. Their gas distributions follow patterns identical to galaxies billions of years older. This uniformity implies processes repeated many times, not a chaotic first cycle. You drift into a cosmic void, observing the distribution of galaxies along its edges. The layout resembles void structures in the modern universe almost exactly. Gravity shapes voids over long spans of cosmic time. But here they appear far earlier. Gravity is not learning these patterns. Gravity is repeating them. You glide past a galaxy whose rotation curve mirrors that of the Milky Way, despite existing billions of years earlier than the Milky Way should have formed. The similarity suggests inherited gravitational architecture. A universe that cycles is a universe that preserves lessons. You drift into regions where Webb uncovered early molecular clouds containing complex carbon structures, complexity usually reserved for much later cosmic epochs. These molecules behave like chemical memory, passed down across cycles. The universe is not starting from scratch, it is resuming a process. You drift onward and encounter more repeating structures, superclusters, filaments, temperature gradients, ionization patterns, all too advanced for a single early cycle. Each cosmic generation appears more refined than the last, as though the universe is learning from itself. You rise above it all, gazing across the vast tapestry of early cosmic structures. The evidence becomes impossible to ignore. James Webb is not revealing a young universe. It is revealing the latest iteration of an ancient one, a universe that may expand, fragment, dissolve, inhale, exhale, and collapse, ignite, restructure, rebirth, over endless cycles. But with each cycle, something accumulates: information, complexity, structure, memory. The universe grows more sophisticated with every iteration, carrying the ashes, the patterns, and the lessons forward. The galaxies you see are not the first. The nebulae are not the first. The black holes are not the first. The molecules are not the first. Everything Webb reveals is part of a much older story, a story that extends backward through cycles without beginning. Ahead lies the next revelation, what these cycles say about the true nature of cosmic evolution, and how the Webb telescope is forcing cosmologists to rethink everything. You drift now into a region where James Webb's observations begin to overturn the very foundation of modern cosmology, the assumption that cosmic evolution must have a beginning. Everything discovered so far, from early galaxies to ancient stars, from massive black holes to mature structures, from chemical complexity to repeating patterns, all points toward a much deeper truth. The universe evolves, but not from zero, not from purity, not from nothing. What Webb sees is evolution layered atop evolution, cycle upon cycle, era upon era. You glide into a field where galaxies sparkle with the maturity of countless generations. Their chemical signatures indicate that their stars have undergone many cycles of birth and death. Their shapes suggest gravitational sculpting, accumulated across immense spans of time. Their black holes carry mass far too great for a single early epoch. This is not evolution from a beginning. This is evolution from inheritance. You drift toward a spiral galaxy, Webb imaged in the deep infrared. Its arms are too organized, its structure too stable, its stars too enriched. According to the traditional model, a galaxy like this should require billions of years to refine itself. But Webb sees it in the first few 100 million years. It is as if the universe carried templates, archetypes, refined across cycles. Galaxies emerge not as primitive structures, but as matured descendants. Their orderliness is not surprising in a cyclic universe. It is expected. You drift deeper, observing how even the earliest galactic disks, discovered by Webb, show professional craftsmanship, not the clumsy early attempts predicted by the Big Bang model. Disks require angular momentum, gravitational stability, and precise distribution of matter. Yet Webb sees disk galaxies so early, it breaks every formation model. Unless these galaxies inherited the conditions needed from previous cycles. You drift above a massive early galaxy cluster where the intracluster gas exhibits high metallicity. Metals require supernova cycles. Supernova cycles require star generations. The cluster has too much complexity for the time assigned to it, but in a universe without a beginning, this complexity fits perfectly. You ascend further until the vista reveals vast filaments connecting clusters, forming a cosmic lattice that resembles a mature universe, not the early, chaotic one the Big Bang demands. This is not growth from simplicity, this is growth from momentum. Evolution here is not a clean arrow starting at a single point. It is a spiral, a repetition, a movement through cycles that accumulate information. You enter a region Webb studied where star-forming clouds exhibit chemical compositions that are already balanced, stabilized, refined. Not raw hydrogen, not primordial chaos, but a mixture of chemically advanced materials, the products of previous cycles of universal evolution. This is evolution without a beginning. Evolution that continues through cosmic rebirths. You drift into a nebula rich with carbon chains and silicon minerals. These require time, extensive time, to form. But their presence in early regions shows that time did not begin where humans thought it did. Time is not a straight line. It is a loop with motion. Webb reveals a universe not young, not newly formed, but ongoing. Part of a lineage stretching backward through cycles invisible to modern measurement. You rise above the nebula, and the interconnectedness of the structures below becomes clear. The galaxies, stars, nebulae, dust clouds, and molecular structures all behave as though they are in the middle of a long evolutionary process, not at the beginning. James Webb is not seeing the start of everything. It is seeing the remnants of earlier iterations, the descendants of structures built across cosmic epochs. A universe that evolves without beginning must carry inherited angular momentum, inherited density waves, inherited gravitational wells, inherited chemical complexity, inherited patterns, inherited structures. Webb detects all of these. You glide now into a region where massive early black holes dominate. Their existence implies previous galactic cycles, feeding them, merging them, enriching them. Their size is not accidental, it is cumulative, the result of cosmic recycling. The traditional model cannot explain this, but a cyclic universe explains it effortlessly. Evolution without a beginning means the universe is a phoenix, falling, rising, burning, collapsing, renewing, with each cycle more complex, more structured, more informed than the last. You float in the silence of intergalactic space, absorbing the depth of what Webb has revealed. The universe behaves like a memory system, not static, not singular, not newborn, but ancient, evolving through cycles that never had a first and will never have a last. Ahead lies the next truth, that cosmic cycles are not only visible in matter, but in the very geometry of space. Your path carries you toward that revelation now. You drift into a region where space itself seems to curve differently. James Webb's observations have hinted at something profound. The geometry of the universe does not behave like the geometry of a singular beginning. Space bends in ways that suggest history, contours that imply repetition, topology that carries memory. You glide into a curved region where gravitational lensing behaves oddly. The distortion patterns do not match what the standard model predicts for a young universe. Instead, the lensing resembles gravitational scars, imprints left by previous cycles of collapse and rebirth. The curvature feels familiar, not random, as though space has been shaped before. You drift closer to a cluster where the bending of light forms intricate arcs. These arcs should reflect mass distribution, and they do, but with a twist. Some lensing patterns imply mass where none exists. These ghost-like distortions are not errors. They are geometric residues, signs that the universe's shape has been reshaped across cycles. Webb revealed lensing fields that appear too tidy, as if space had time to relax into equilibrium. Equilibrium requires unimaginable durations, but Webb sees it already achieved in the earliest eras. You glide into a cosmic void where the geometry of emptiness is too smooth. Voids reflect mass distribution. Older universes have refined voids. Younger universes have tumultuous voids. Yet the early voids Webb sees resemble old ones. Space remembers. You drift into regions where the geometry shows repeating fractal patterns. The large-scale arrangement of galaxies mimics patterns seen in far later cosmic epochs. The fractal dimension appears consistent across space and time. This consistency suggests not one cycle, but many. You rise into a region where Webb observed temperature gradients in surrounding gas clouds. These gradients reflect thermal histories, not a singular history, but layered histories accumulated over cycles. The geometry of heat itself carries memory. You approach a filament whose spatial curvature matches predictions of cyclic cosmology models. Expansion followed by contractions imprint density waves on the cosmic lattice. These waves leave ripples in space's geometry. Webb sees them clearly. You glide deeper, entering a region where galaxy distributions form ancient-looking arcs, the shapes of gravitational resonances that require enormous timescales to develop. But Webb found them near the supposed beginning. The universe did not suddenly form these shapes. It reused them. You drift toward a region where early galaxy clusters reveal geometry too symmetrical for a universe just finding its structure. Symmetry at this scale is the hallmark of long-term gravitational smoothing. This smoothing takes billions upon billions of years, but it exists in the earliest structures Webb observes. You rise into the higher dark, letting geometry reveal the truth. Space behaves as though it has collapsed and re-expanded many times. Its curves are not the curves of a new universe. They are curves of an experienced one. Webb's geometry data reveals cycles hidden in the shape of existence, gravitational scars, density echoes, topological repetitions, void smoothness, filament symmetries, lensing patterns, fractal consistencies. These are not the features of a universe in its first iteration. These are the features of a universe that has lived and lived again. James Webb did not break cosmic geometry, it exposed its memory. The next revelation waits ahead. How these cycles shape not only matter and space, but the very flow of cosmic energy itself. You drift onward, deeper into the realm James Webb has illuminated, where the mysteries shift from matter and structure into something even more fundamental: energy. Because what Webb reveals is unsettling. The cosmic energy budget does not behave like the energy of a universe only a few 100 million years old. Energy fades over time, energy disperses, energy cools. But Webb sees regions where energy seems too abundant, too concentrated, too persistent, as if the universe has carried it across cycles. You approach a swirling galaxy discovered by Webb, whose infrared emissions pulse with unexpected intensity. The galaxy radiates far more energy than its age would allow. Its stars burn with furious light. Its gas glows with the heat of rapid, efficient star formation. Its dust radiates warmth that should require long-term energy accumulation. This is not newborn energy. This is recycled energy, or energy preserved. You drift closer. Webb measured regions within this galaxy where starbursts erupt with impossible vigor. Starburst regions require enormous reservoirs of gas compressed over time. But this galaxy exists far too early for such reservoirs to develop naturally. It is as if energy from previous cycles has been funneled into new structures. You glide toward another anomaly, a quasar blazing brightly in the early universe. Its luminosity is immense, powered by a black hole devouring matter at astonishing speeds. But quasars of this scale should only exist after long spans of galactic evolution. Yet Webb observes them practically at the dawn of time. Energy does not appear this concentrated in a young universe. It requires history. You drift on. In another region, Webb detects shock fronts, waves of energy rippling through gas clouds, typically caused by supernovae or past mergers. But the number of shock fronts is too high for the early cosmic timeline. The universe shows signs of violent, energetic events that should not have happened yet, unless they occurred before the current cycle. Energy leaves footprints. Webb is reading them. You pass into a nebula, glowing with strong infrared radiation. The amount of heat present implies a history of intense stellar activity that cannot be compressed into the tiny time window the Standard Model offers. These nebulae behave like relit furnaces. You drift onward. Then comes something even stranger. Webb detected ionized gas in places where ionization should not yet exist. For gas to be ionized at this scale, either a massive source of energy must be present, or the gas must have survived from a previous high-energy state. The early universe was supposed to be dark, neutral, slowly lighting up, but Webb shows regions that were already lit, as if the universe never fully reset. You glide toward another region where Webb saw extreme ultraviolet radiation permeating early galaxies. This radiation requires enormous amounts of energy, more than newborn galaxies should produce. But if cosmic cycles preserved pockets of energy, compressed during contraction phases, then released during renewed expansion, such regions become not anomalies, but expected. You rise higher. James Webb also found unexpectedly warm dust in early galaxies, dust that glows brightly in the mid-infrared. Dust takes long periods to heat and cool, shaped by cycles of stellar evolution. Yet Webb sees dust as warm and developed as dust billions of years later. Energy remembers. Dust carries the warmth of past eras. You drift into the void between galaxies. Even here, Webb detects faint ultraviolet signatures, trails of energy scattered through intergalactic space. The Standard Model cannot explain how such energy traversed distances so quickly, but energy passing across cycles explains it perfectly. In a cyclic universe, not all energy dissipates. Some is carried forward, trapped in black holes, compressed into matter, stored in radiation fields, encoded in gravitational waves. Webb sees the remnants of all of it. You drift in silence, feeling the cosmic warmth around you, the kind that should not exist in a universe so young. But Webb's universe isn't young, it is layered. Energy that refuses to fade suggests cycles that refuse to end. And ahead lies the region where these cycles reach their most dramatic phase, where the universe collapses, not into cold death, but into the seed of its next rebirth. You drift forward. You drift into a region where James Webb's discoveries begin to outline a cosmic possibility once dismissed as myth, that the universe lives through grand cycles of collapse and renewal. That creation is not a single event, but a rhythm, a breathing, an inhalation and exhalation, a cosmic heartbeat, This region contains clues that point toward that rhythm. You move toward a massive cluster where Webb observed galaxies swirling in coordinated patterns, as though responding to ancient forces. Their motions appear to follow curves not entirely dictated by present-day gravity. Some motions suggest residual momentum, leftover motion from a previous collapse. The universe does not forget its earlier inhale. You drift toward a galaxy whose stars orbit with unusual dynamics. Their velocities match predictions for matter that survived a previous compression phase. These stars behave not like newcomers, but like veterans of multiple cosmic epochs. Webb sees stars that seem to carry the cadence of earlier universes. You glide across intergalactic space, sensing gravitational fields that behave oddly, as though the universe's fabric was stretched, relaxed, compressed, stretched again. Gravitational scars from earlier contractions. You approach a filament whose density waves match models of a universe that collapsed before re-expanding. These waves echo through space like ripples frozen in the act of reversing direction. The universe breathes. Webb captures the breath. You drift deeper and discover a vast region where galaxies flow toward a great attractor-like structure. Their motions are too aligned, too coherent. They appear to remember the gravitational center of a previous universe, a place where everything once collapsed. Patterns of infall carry memory. You glide along this flow, feeling the gravity tilt subtle directions. This flow cuts across cosmic epochs. It was too early for such patterns to form, unless they began before the current cycle. You drift through a galaxy whose central black hole appears too dense, too massive, too ancient. The black hole's mass implies it accumulated matter not just from this cycle, but potentially from earlier universes collapsing into it. Black holes may carry mass forward across cycles like seeds. You drift toward an early quasar. Its power suggests that black holes continued accumulating matter through the collapse of a previous cosmic epoch and ignited once again when expansion resumed. The universe does not erase itself, it reincarnates itself. Webb captured evidence of this reincarnation physically, not philosophically. You rise above a region where Webb identified early galaxies showing double-phase evolution, traits of young galaxies mixed with traits of ancient ones. Their chemical compositions exhibit dual histories. Some call these rebirth galaxies, where matter from prior universes coalesced into the new. You drift toward a region where temperature patterns in ionized gas match theoretical predictions of a universe that underwent a contraction. The gas appears reheated, as though compressed before being released. Compression leaves thermal fingerprints. Webb saw them. You drift through regions that seem eerily balanced, as if the universe started not from chaos, but from a smoothed, restructured state. The aftermath of collapse, rather than the explosion of something entirely new. Signs of contraction, residual momentum, gravitational asymmetries, thermal imprints, chemical gradients. Mature structures too early. Signs of renewal, rapid star formation, massive early black holes, galaxies forming instantly mature, repeating patterns, preserved energy. Webb's universe does not look like something beginning. It looks like something resuming. You drift toward the horizon of this cosmic understanding, and the final truth approaches. The universe was never a one-time creation. It was never a singular explosion. It was never young. Everything Webb observes points toward a vast, eternal cycle. Collapse into density, renewal into expansion, growth into complexity, dissolution into collapse, over and over. Ahead lies the final revelation, what all of this means for humanity's understanding of existence itself. You drift into the final domains where James Webb's revelations weave into a single profound truth. The universe is not fragile. It is not fleeting. It is not marching toward an inevitable end. Instead, Webb's discoveries whisper a radical idea into the cosmic dark. The universe does not die. It transforms. You glide into a region where distant galaxies flicker with the faint glow of their final stars. These galaxies appear exhausted, their fuel nearly spent, and yet they still radiate patterns of order. Even in decline, their light is organized, structured, almost intentional. This is not entropy consuming the cosmos. This is evolution preparing for the next phase. You drift closer. James Webb captured galaxies in advanced states of aging far earlier than expected. These galaxies show traits typically associated with the late epochs of a universe: faded disks, weakened star formation, aging stellar populations. But these should not exist so soon. Unless the universe is older, far older, cycling through phases of youth and age across eternal timelines. You glide through one such galaxy. Its stars burn low, its interstellar gas depleted, but the galaxy's gravitational structure remains stable, poised like a skeleton, waiting for new flesh. This galaxy feels like a memory, a remnant of an earlier cycle, preserved into the next. You drift onward into intergalactic space, where faint radiation from old stars lingers like an afterglow. Webb's infrared instruments detected this faint light, too widespread for a young universe, too uniform to be from isolated sources. The cosmos is filled with a background of recycled energy, radiation from previous eras, carried forward like a universal heartbeat. You follow this ancient glow to a massive cluster. Some galaxies here appear to be fading entirely, leaving behind cores that shine with minimal brightness. These galactic remnants resemble embers cooling after a fire, the final stage before collapse. But collapse is not death. Webb's observations imply a sequence. Galaxies fade, clusters thin, matter flows inward, gravity intensifies, the universe contracts, not permanently, but rhythmically. You drift through space-time where Webb detected surprising gravitational alignments. Large regions of matter appear to be drifting subtly inward, not enough to contradict expansion, but enough to suggest long-term oscillation. The universe expands and contracts in ways too slow for humans to perceive, but Webb leaves hints: the geometry, the motion, the symmetry. You move toward a vast void, an emptiness stretching across millions of light years. But even here, patterns exist. The void's smoothness implies immense time spent emptying matter, as though preparing to be part of a future collapse. Voids are not accidents. They are inhale spaces. They are where the universe gathers itself. You drift through a filament feeding into a massive, elliptical galaxy. The flow of matter is steady, ancient. These flows resemble arteries returning material to gravitational hearts, the early stages of a gathering that leads to cosmic contraction. Webb's data reveals galaxies whose shapes align in ways suggestive of inward drift, long-term tendencies, not one-directional expansion. You glide above the massive elliptical galaxy and sense the weight of its central black hole. Webb found black holes so large, so overgrown, that they appear ready to become the seeds of future universes. Black holes might be cocoons, not graves. In a cyclic cosmos, these massive black holes could accumulate matter through collapse and then release it through renewal. Webb's infrared observations capture their quiet hunger, their readiness to gather matter at the end of each cycle. You drift toward a region where galaxy clusters form giant arcs, curves predicted by some cyclic models, but not by a universe created once. Their symmetry suggests gravitational flows that operate over cosmological cycles. Webb is not witnessing the early universe. It is witnessing the middle of an eternal process. You move upward into darkness, letting the cosmic tapestry reveal its full scale. Everything you've seen, early maturity, ancient stars, huge black holes, repeating structures, inherited patterns, energy echoes, converges into one truth. The universe is not on a linear path toward death. It is spiraling through infinite cycles of transformation. Stars form, stars die, galaxies merge, structures fade, energy compresses. The universe contracts, then expands again, carrying forward the memory of what came before. Nothing is lost, everything becomes part of what comes next. James Webb didn't simply break the cosmic models humans created. It showed that those models were too small. The universe is not fragile. It is eternal. It will not die. It will change. Ahead lies the final understanding, the meaning of the universe revealed by Webb's impossible observations. You drift toward it. You drift into the final region illuminated by James Webb. Not a place in space, but a place in understanding. Here, the anomalies, contradictions, and impossibilities resolve into a new story. A story not of a universe that began suddenly in a flash, not of a cosmos racing from infancy to maturity, not of a fragile timeline measured from a single moment, but a story of a universe that cycles, evolves, remembers, and renews itself endlessly. You descend toward a galaxy glowing with impossible maturity. Its stars whisper the memory of earlier cycles. Its dust carries the warmth of long-lost suns. Its shape reflects ancient gravitational habits. This galaxy is not merely an object, it is a lesson Webb has given humanity. Do not mistake the visible cycle for the first cycle. You drift further into the deep field. Galaxies swirl and dance in patterns repeated across unimaginable epochs. Structures appear too refined, too symmetrical, too familiar for a universe supposedly young. Webb saw a cosmos that has been sculpted before. The more you look, the clearer the truth becomes. The universe is not new, it is practiced. You glide across a nebula filled with complex molecules formed too early. These molecules do not belong to a first attempt. They belong to a cosmic lineage, a chemistry practiced across cycles. The universe learns, the universe evolves, the universe remembers. James Webb didn't simply show us old galaxies in a young universe. It showed us a universe that never fit into the story we wrote for it. You rise into a region where massive black holes anchor early galaxies. Their mass is outrageous, impossible, unless they are ancient engines carried forward from previous cycles. Black holes are not endpoints, they are bridges. They preserve matter, energy, even information across cycles. You drift further. Webb found repeating structures, cosmic webs, filaments, clusters, voids, all too mature for their place in the timeline. These structures are not random. They are inherited memory patterns of gravitational evolution. The universe is fractal, not because it was born fractal, but because it became fractal across cycles. You glide upward, gaining a view of the entire cosmic landscape Webb has uncovered. Every contradiction becomes a clue. Early galaxies too complex, stars too old too soon, black holes too massive, patterns too familiar, matter too enriched, voids too smooth, structures too large, energy too persistent. Each anomaly breaks the standard model. Together they build a new one, a model where the universe did not begin, a model where the universe continues. You drift deeper into the dark, letting the final understanding settle. The universe is not a story with a first chapter. It is a story with infinite chapters, one cycle giving rise to the next. James Webb has shown that every atom, every star, every galaxy carries the memory of what came before. Cosmic evolution is not a linear timeline, but an eternal recursion. You move toward a swirling vortex of newborn stars. Their light is young, but their ingredients are ancient. Their molecules have lived across cycles. Their dust has carried the echo of entire universes. Creation is not a beginning. Creation is a continuation. You glide across a supercluster, glowing faintly in the infrared. Its galaxies form waves, arcs, and patterns reminiscent of cycles too vast to imagine. The universe is not static, not linear, not singular. It is dynamic, circular, and eternal. You move now beyond the galaxies, beyond the filaments, beyond the voids. The universe stretches endlessly in every direction, filled with memories, filled with history, filled with potential. And then, in the silent dark, Webb's message becomes clear. We are not living in a 14 billion year old universe. We are living in one moment of an eternal cosmos. Humans believe the universe began. James Webb is showing them it persists. No beginning, no end, only transformation. You drift in the soft darkness one final time as the truth settles within you. The cosmic story was never about how everything started. It was always about how everything continues. And the universe, ancient, eternal, cycling, remembering, continues still.